For video 4, we're going to be talking about matrices. So let's go turn together to the matrix portion of the review. Matrix problems. All right. This company has offices in 3 cities, and it manufactures widgets in 4 sizes: small, medium, large, and jumbo. So I'm going to assume this is small, medium, large, and jumbo. This is Cleveland, this is Columbus, and this is Cincinnati. These rows. The predicted sales for January is in matrix B. The selling price for small is $8, for medium is $12, for large is $15, and for jumbo it's $18. Suppose the actual sales were 10% higher, and this shouldn't say for each month. Find the revenue for all types of widgets at each location. So first we need to find a 10% increase of these sales. And again, if we have a number and we want to increase it by 10%, I'm going to multiply it by 1 plus 0.1. So I don't just have a number, I have an entire matrix. And that's 1100. This does the 10% increase. 1000, 1800, 800, 950, 600. Oh man, it doesn't fit. This is 700, 750, and 800. So I'm going to pause this real quick. Okay, so I did that multiplication and we got this matrix right here, so I'm going to call this C. Basically what you need to do to find the revenue, we need to find this matrix product of C for revenue. I will do C times P, where P is this matrix up here. And because I don't have enough space, I am going to just leave it as C times P. And I will pause it again so you don't have to sit through me typing all that in. And I will just unpause for the final answer. Boom, and there's your answer. So this first row is going to be Cleveland. Second row is going to be Columbus. So U, U, M, B, U, S. And the third row is Cincinnati. So that would be your final answer. All right, number 2, this is a geometric transformation problem. So we have a triangle and we have 3 vertices, A, B, and C. First, we need to write the matrix which describes the 3 points. So let me do that. P is equal to 0, 0, 1, 2, and 3, 6. Look at me following directions. And now I need to find P prime, which is 1, 0, 0, negative 1, times 0, 0, 1, 2, 3, 6. And I can just do that in my head, but it's okay if you can't and need your calculator. This is going to be 0, 0, 1, negative 2, and 3, negative 6. That is P prime. I want to do a little bit more investigating though. I'm going to see what actually P prime, what this multiplication did. So let me plot P, 0, 0, 1, 2, and 3, 6. This is going to be a bad triangle. It's really skinny. Sorry about that. That's the worst triangle ever. And this is going to be this triangle right here, 0, 0. Oops. Sorry. 1, -2, and 3, -6. Ugh. Again, very bad. I think this is what it looks like. Basically, to get from here to here, what this does, it reflects across. X-axis. Didn't ask for that, but it's really, I think it's helpful to understand what those multiplications are doing. Let's go ahead and look at number 6, which is a transition matrix. Okay, so we know this is for this week and this is for next week. 30% who were late for school last week will be late this week. So if we're in this week and they're late, that means next week they're going to be late too. 70% of people will not be late for school. The remaining 70%. So these are people who were late this week and won't be late the following week. So that's where that 70 goes. 40% who were not late will not be late. So they're not late 2 weeks in a row. Awesome. Good for you. That's where that 40 goes. The remaining will be late. So if they were not late this week, they will be late next week. I wonder why. Maybe bad weather. Who knows? So I already did this. Check. I did that up there. This week, 32 students were late and 450 were not. Use matrix operations to determine the number of people we expect to be late this week. So I have my transition matrix, 30, 70, 60, 40, and I'm going to multiply it by another matrix. This is 2 by 2. This one has to be 2 by 1. So my result will be 2 by 1. Okay. This row was late. This is not late. This row. So on top, I want to put the students who were late, which is 32, and on bottom, I want to put 450. Those are the ones who are not late. So let me do this real fast in my calculator. Okay. So it'll give you 279.6. This is 2.4. So 279.6, sorry, which is approximately 280, will be late. Sad face. Oh, and that's it for matrices.